Assalamualaikum. My name FAIZ IHSAN. My matric number 181093056. I am from Group 2. Our team members MOHAMAD, HAFIZ and Akhmal-Danial. We are going to present the SCADA system and application of SCADA system for our subject EMJ 44103 Power System Operation and Control. Okay, firstly, what is SCADA system? SCADA stands for Supervisory Control and Data Acquisition. It is an industrial computer-based control system employed to gather and analyze the real-time data to keep track, monitor and control industrial equipments in different type of industries. Consider the application of SCADA in power system for operation and control. Architecture of SCADA. Generally, the SCADA system includes the following components: local processors, operating equipment, PLC, instruments, remote terminal unit, intelligent electronic device, master terminal unit or host computers, and a PC with a human-machine interface. Three types of SCADA system. There are different types of SCADA system that can be considered as SCADA architectures of three different generations. First one is monolithic or early SCADA system for first generation. Second one is distributed SCADA system for second generation. And then for last one is network SCADA system for third generation. For monolithic SCADA system, mini computers are used earlier for computing the SCADA system. The earlier times during the time of first generation, monolithic SCADA system were developed where the common network service were not available. Hence, this independent system without having any connectivity to other system. And then for distribute SCADA system, in the second generation, the sharing of control function is distributed across the multiple system connect to each other using local area network (LAN). Hence, the word term as distributed SCADA system. These individual sections were used to share real-time information and common processing for performing control tasks to treat the alarm level of possible problem. And then for network SCADA system, the current SCADA system are generally network and communicate use wide area network (WAN) system over data line or phone. This system use internet or fiber optic connection for transmitting data between the nodes frequently. This third generation SCADA system use programmable logic control (PLC) for monitoring and adjusting the routine flagging operation only in case of major decision requirement. Okay, in this configuration, any combination of component may be used to support the load. This gives more flexible than separating component into a redundant system, but it requires shared control of all components, making the PLC as possible single of failure. These are for step in configure SCADA system. Firstly, sensor transmit data to PLC or RTU, or manual input transmit data to PLC or RTU, and then PLC or RTU feed data to SCADA system. After that, transfer to HMI SCADA panel view for local process control and for remote process control.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Akhmal-Danial bin Rahim. My matrix number is 181093052. Today I will present about the SCADA communication and protocol. There are three types of SCADA standard protocol. First is IEC 61850, and next is IEC 60870, and next is DNP3. All the major SCADA vendor standardize and recognize this communication protocol. Many of these protocol have been enhanced and now include TCP or IP extension module. First is IEC standard for 60X70 and 61X50 is the extensionality using for the management of electrical power transmission network and other industrial facility. This standard may be used to the interoperate device from the manufacturer user established protocol. Okay, next is DNP3 standard for distribution and network protocol, and is a collector of the communication protocol utilized between the component in the process automation system, such as the power utility and the chemical process facility. That's all about the communication and the protocol. And then I will go to the contribution of the SCADA in the system. In today, the digital world, digital world, we explore a new opportunity to automate and accelerate our industrial process and operation. Since the in, since the invention of computer and the internet, and machine system has integrated computing technologies. This is show that the importance of the SCADA contribution, especially in the industrial. The type of industrial that being contribute in this SCADA system is energy industrial, manufacturing, power, transportation, food, oil and gas, recycling, and water and wastewater. Next, I will present about the advantage and disadvantage of this SCADA system. First, the advantage of this SCADA system is the maintenance is efficiency, distributed data for smarter decision, and communication system issue to reduce the downtime. Next the advantage is simple configuration to the larger and complex installation. The disadvantage for this SCADA system is, first is it require the skilled person to maintain it. Next is support used to restricted software and the hardware equipment. That's all for my presentation for this SCADA. Thank you.
Crude oil refineries produce LPG, naphtha, gasoline, kerosene, and diesel, which we use daily. SCADA screen attached to a PLC through communication cable monitor upstream and key process sections such as wellhead, manifold ore gathering, separation, gas compression, metering, storage, and export. The plant has 7 main cycles, each with several input and output signals connected to PLC controller and WinCC based SCADA system to monitor the system. SCADA improve operation, maintenance, process development, and so on. A SCADA software program and hardware interface are put on oil and gas production and refineries to establish a real-time application management environment. The SCADA GUI are presented to monitor and control refinery gas processes, which include the following components: So in this window, display that when you press the drilling switch button, the drill motor begin to operate and crude oil is drawn from the underground pipe and transferred to a crude oil tank for further processing. This window shows that a crude oil from the tank is passed through a heater where various products are separated based on their boiling point, such as naphtha, LPG, kerosene, gas oil, and straight run residue, which is then sent for further processing. In this unit, the separated crude oil or straight run residue is fed into the heater so that the remaining water is removed completely and then run through horizontal vessel and fed again into the reactor from the LPG and naphtha gets separated. In this window, crude oil is distilled. Distillation separate a mixture of hydrocarbon depending on their boiling point or range. Lighter hydrocarbon boil and vaporize first when heated. Cool and condensed vapor generate a fraction. Crude oil distillation separate crude oil into parts where defined boiling range. Pump discharge LPG, naphtha, gasoline, kerosene and diesel from the distillation tower at the distillation unit and feed them to their storage tank in the product storage or distribution unit. The LPG metering station measure the quantity of gas moved from production region to consumption region.